everyone. I'm Linda Nickell, and welcome to the Happiness Hour. Every week, photographers meet here to connect, inspire, and create. You can find the schedule for upcoming sessions on my website at lindanickell.com. My guests share their photography tips and insight into their creative projects, and they inspire us to look at a subject a little differently. Tonight's guest is Luca Vanzella. That's right. Luca is a skyscape photographer whose work focuses predominantly on the moon, the sun, and the planets in the night, twilight, and daytime skies. Timescape photographs are predominant in his work because they depict the movement of an astronomical object in the sky during a certain span of time. Luca's projects have been featured on NASA's Astronomy Picture of the Day, and you can find his gallery of work on Flickr, and I'll link that in the show notes. In tonight's presentation, Solstice Sunrise Across the Latitudes. To complete his latest project, Luca organized a group of photographers to capture sunrise across the planet near two dates, the June Solstice and the December Solstice, to illustrate the change in sunrise azimuth from solstice to solstice as a function of latitude. Welcome to the Happiness Hour, Luca.
Thanks for having me, Linda.
Sorry, I stumbled all over your introduction.
That's okay.
Those were very big words for this little girl from Texas. So thank you for, okay, let me just start with disclosure, because sometimes I get asked, hey, how did you find your speaker? Or how did you get that person to come and do a presentation for us? And your story and my story is one I haven't ever gotten to share or have this happen. But you had reached out to me, I think via I guess it was through email, through my website. And you asked me, hey, I'm looking for somebody to help me with my project, which is this project. And would you be interested, or could you help me? And I said I couldn't or wouldn't. I don't really know what my excuse was, but I was like, I don't think I'm qualified to help you with this, but let me find you somebody. And then I turned it around and said, hey, you come to the presentation for my group because I think this is a really cool project. And you didn't even hesitate. And for that, I so appreciate it. So tonight, as I'm doing your intro, I don't know a whole lot about you other than just a few minutes before we got on. You're based in Edmonton, Alberta.
That's right.
And this is your passion project, right? Photography is not this is not your thing. This just helps you kind of, I don't know, have something to show for the stuff that you're doing with are you using telescopes? Is that your passion?
Well, my main passion is amateur astronomy. So I like looking through telescopes under dark skies. And a natural progression when you do that, it would be to do astrophotography of dark sky objects like galaxies and star clusters and things. But then you spend a lot more time in front of a computer than you do at a telescope. And so I stayed away from that and just took up skyscape photography because that happened when it wasn't dark, and so it wouldn't take away from telescope time. So my main passion is astronomy, and this is a sideline of astrophotography of things in the solar system, mainly the moon and the sun.
What made you think about this project? What was the motivation? Just a cool idea, or did you have something in mind?
This particular project is the latest in a series that I worked on since about 10 years ago, which was I began thinking about not just skyscapes to show an interesting scene with an object like the moon or the sun above a skyline or landscape, but also to try and think about the motion, the dynamics between Earth, sun, and moon. So it would be Earth turning, the Earth going around the sun, and the moon going around the Earth. And so that evolved into other types of photography, which started off as skyscapes and then became timescapes because I was starting to depict the passage of time in a single image. And so eventually they, over the years, led to this particular project, which I will describe in this presentation. So I'll show some of a little bit of the previous projects that led to the inspiration for this one, so you can see how it sort of evolved. But it's been about 10 years, not that I was thinking about it for 10 years, but 10 years of working on various things that eventually led to this crazy idea of lining up a bunch of photographers to try and get these solstice pictures.
Well, all right. I'm going to let you get started because I know
Okay.
that just kind of my preview of your slideshow, you've got a lot of stuff to cover, and I don't want to cut you short anywhere. So with that, this is all yours.
Okay. Thank you very much. In fact, there's been a slight name change in the project. It's not quite, it started off as Sunrise Across the Latitudes, but I changed it to Across the Planet, and this was sort of a follow-up title from a previous project that I did. But I'm going to talk about, so I'm going to talk a little bit about the types of photography I do and some previous projects, and then how this one came to be. But I'm going to start off with the whole thing, and this is it. This is the image, which is the result of the project that it was finished last month. So the solstice sunrise across the planet. So this is a composite image it's a collaboration of 13 photographers, myself included, that shot sunrise at the June solstice and at the December solstice in the past year in order to put together this collage showing that the angular distance between the sunrise positions at the solstices changes as a function of latitude. So on the 13 images on the left-hand side represent June solstice sunrises, and the 13 strips on the right is the December solstice sunrises. So it's centered on the equator. The strip in the middle is the equator, and we go up north to about latitude 60 in about 10 degree spans, and then southward towards the South Pole in about 10 degrees spans. And so this was the project to produce this particular picture. And you can see I've just annotated it briefly here so you can see the latitudes that it covers. So we go from very nearly bang on the equator to basically latitude 60 in the northern hemisphere, and not quite to latitude 60 in the southern hemisphere. And that was mainly due to a lack of, there's not as much land in the far south of the planet. And so there's not very many places where you could even shoot at latitude 60 south of the equator. So we ended up having to cut it off. And there's some things about this photo that you might be noticing, or this image that you're noticing that I'll get to talk about why it looks the way it does. But this was the representation that I was hoping to achieve. And so the project was about a year in the making because it needed at least 6 months to go from June to December. But there were a couple of issues in getting the shots from 2 of the latitudes by December, and so a couple of photographers had to drop out, so I had to recruit new ones, and so it took a little bit longer, and so it was basically a year in the making. But it should have been doable in about 6 months, but it took a year of elapsed time to do it. And so the type of sky photography that this project resulted from is the kind that I generally like to do, as Linda mentioned in the introduction, skyscapes. So I like taking pictures that depict an astronomical object low above the horizon, either a landscape or a cityscape, and try to capture the scene as it might look if you to the photographer with the naked eye, right? Just standing there looking, maybe with a pair of binoculars for zooming in a little bit, but just how it might look with trying to depict it as you could see it with your eyes. So I've done a lot over the years with moonrises. You can see a twilight moonrise over the city of Edmonton on the top left, and then an evening moonrise or a little bit closer to the skyline in the top right. Those are moonrises. And there's for full moons, there's an opportunity once a month or once every 30 days or so to be able to get full moonrises or sets over the low horizon. And the ones on the bottom are sunrise shots, and those are examples of 2 images I took for different previous projects depicting sunrise. So on the bottom left is a winter sunrise with the sun near the southern extreme of its rise point near the December solstice. The one in the middle is the one on the bottom right is what I did around the equinox of 2022 for a different project, and you'll see something. You'll see how that image was used in another around the world project that I organized. So these are skyscapes, and over the years I've kind of honed it down to two golden rules that I like to apply to the work I do, which for the skyscapes, and that is that one of them is that the size and position of the astronomical object in the sky must be correct with respect to the landscape. So I don't want to fake anything. I don't want to take two different pictures, one of the landscape and one of the object like the moon, and combine them together from different shots or different time. They need to be correct with respect to each other in terms of position and size. So no faking it, right? If you want to get a large moon above the horizon, like you can often see with the large moon illusion low over the horizon, you have to put yourself at a distance from the skyline or the landscape and zoom in to get an effect like this. But this is a single shot, not a composite for blending lighting conditions or anything like that, but a single shot of a moon just coming up over the horizon during the summer in our river valley. So that size and position was exactly as we saw it as we watched it rise. It's zoomed in, but otherwise it's what you would have seen. The other rule that I like to have on doing all of the skyscape photography is that I use one camera, one lens, one focal length, and one camera position. So in this shot, here's an example of setting the camera up to do a sunrise shoot. Just put it down, set your parameters, frame your image, and shoot one or multiple images to produce something. And there's no movement. So that way if you're overlaying things, you don't have to worry about registration or alignment issues, and it just keeps everything consistent, and it aids, of course, in making sure that the astronomical object, like the moon or the sun, is in the right spot in the sky and is of the right size compared to the landscape. So I like to operate with those things. So everything you see here that I did over the years was using these two techniques. So eventually, as I mentioned, skyscapes evolved into timescapes, which was not only to shoot a skyscape, but also depict the movement of that object in the sky over a time span, which can be short or it can be long. So the top two examples of top left is a moonrise over the city, and top right is a moon set over the city. And so here you put still one camera and one focal length, one lens, one position, all of those things, but it was shot multiple times. And so you end up with a composite image with a spacing of about 5 minutes. And that's how much the moon moves in about 5 minutes in the sky. And the time span is roughly about 30 minutes. So on the top left, we've got a rise and exiting the frame in about 30 minutes. And on the top right, the set, entering the frame, and then setting behind our Capitol building, our legislature building about 30 minutes later. And so not only is the passage of time depicted, especially in these moon shots, you can also see changes in color of the object, right? Atmospheric refraction changes the color of the moon as it rises and sets. It also changes the shape. You can I don't know if you can notice it on your screens, but the really low moon is not quite round compared to the moon higher up in the sky. It's much more circular, and that's due to atmospheric refraction effects as well. So you get those kinds of changes. Also, the lighting of the scene changes in twilight, whether you're working towards the end of civil twilight, in the middle of civil twilight on the top left picture. So I use a representative lighting picture for the skyline and the sky to depict that roughly the lighting of that 30 minutes. And on the right, it was closer to the transition between nautical twilight and civil twilight. And so I did a blend of a couple of sky images in order to show the sky color changing in roughly the time period of 30 minutes. So did a lot of work with moon rises and sets over the years. And then eventually I got onto the idea of shooting the sun and shooting skyscapes or timescapes with regards to the sun. So And the thing is, I live at latitude 53.5 degrees north of the equator. And so there's quite a variation in the position of the sunrise or set between June and December. Despite a popular misconception that the sun does not always rise in the east or set directly in the west. Where we live up in northern latitudes, it rises in the summertime, and in June it rises far in the northwest, far in the northeast, and sets far in the northwest. So a couple of projects I did was based on two solstice dates. One, the bottom left picture is a camera facing due north in our city, and I took a picture at around 10:04 p.m. On the left, I took a picture of just before the sunset at 10:04 p.m. And then about 7 hours later, that the camera is still facing due north, I was able to shoot the sun coming up in the northeast. And so that is on the shortest night of the year for for Earth. And you only get about 7 hours where the sun is below the horizon. And if you stood there, you could watch sunset to sunrise without having to turn your head, and that's basically what the camera did over the course of about 7 hours. The other solstice is the December solstice, which in the north is our winter, and that's the shortest day of the year in the northern hemisphere. And so for us, the sun follows a very low arc in the daytime sky. It's only up above the horizon about 7.5 hours on the shortest day. So a few years ago, I set up a camera at a friend's up top of a friend's apartment tower, and I pointed the camera due south, and I shot the sun through a solar filter attached to the lens throughout from sunrise to sunset, and then composited that in with 3 foreground images to depict sunrise lighting on the left, daytime lighting in the middle, and then sunset lighting on the right. And so that's the low arc. The sun never gets above 14 degrees above the horizon at its highest altitude at midday. And what's 14 degrees above of the horizon? Well, that's the height of your fist held at arm's length, 3 fists held at arm's length in front of you. That's about as high as our sun gets. So days are really short, and it's a very, very low arc. In fact, Astronomy Picture of the Day had posted one of these pictures several years ago, and was inspired by that one to try for this one. The blown out sun there, just as a note, that I included in the composite one in the daytime image in the middle there that shows the sun unfiltered, and that's how overblown it is if you don't use a solar filter. But otherwise, the disk of the sun, as you can see, is very, very small when you shoot at a very, very wide angle, right? Again, it's an accurate depiction of how big the sun is in the sky when you're shooting that wide. So both of these bottom pictures on the bottom here, on the left and the right, are showing what happens with the sun's position at sunrise and sunset at the solstices. And of course, the positions of these things are all really a function of the Earth's orbit around the sun and the tilt of the Earth's axis of its rotation with respect to that plane. And so one of the things that I embarked on about 10 years ago, which was sort of one of the main precursors of this evening's, the project I'm describing this evening, was something called the solar analemma. You may have seen pictures like this before. And if anybody still has a globe, you often see that in the legend of a globe, which is this shape of a figure 8. And so what this is the result of shooting the sun, again, through a solar filter at the same time every week or two throughout the course of a year. So you pick a time of day. In this case, it was at 10 minutes to 9:50 a.m., 10 minutes to 10 a.m. In the morning. So I'd set up a camera at a fixed location at a park overlooking the river valley, and I'd shoot the sun through a filter. And you do this without moving the camera, and at the same time every day, the resulting collage of images looks like this, blended with a scene. Because it took all year to do this, Could have blended it with a winter scene. I chose a summer scene to represent it. So the foreground isn't really representative of the time, because you have to pick one. And over the course of a year, one picture does not always represent the climate for most locations on Earth, or the conditions. But in this case, I chose summer, but the shape is showing where the sun is in your sky at 9:50, in my sky at 9:50 every morning, if I shoot every week or so at the same time of day. And so the up and down portion is a result of the Earth's tilt, the tilt of the Earth's rotation, the axis of rotation, the tilt with respect to the plane of its revolution around the sun. The tilt of the figure eight is the result of me choosing 9:50 in the morning to shoot it. If I had a shot it closer to midday, then it would look more upright. And then the left to right shifts are the result of the difference. It's a fancy term called the equation of time, but what it really means is a difference between clock time and solar time. So clock time is what we all use, which is 24 hours exactly every day. But the Earth doesn't rotate in 24 hours exactly. It's 23 hours, 56 minutes, which is why we have leap years. And so that little bit of a shift accumulated over the course of a year gives this resulting figure eight appearance if you shoot that. And so this is a timescape, and the time span is the course of a year. This, just as an aside, this used to be attempted by photographers in film days, and where you expose the same piece of film to the scene, and then one exposure for the foreground. And very, very difficult, because if anything happens in the course of a year with your camera's position moving, the resulting picture was destroyed. With digital techniques, it's a little easier, because if one doesn't work out, you know it right away, and you can go shoot again. And if you're only shooting every week or two, you have some forgiveness in terms of if it's not clear that day, or if you've had a problem. And that's why you'll notice the spacing isn't exact. Some days are cloudy, you can't get the shot. Other days are good, and you can. And so this is a timescape over the course of a year. And all of this, as I mentioned, just a quick primer, is a result of the Earth's orbit and its rotation. So the Earth orbits the sun not in a circle, but in an ellipse. And this is exaggerated in this diagram, but it is an ellipse. It's not a circle. So that means the speed changes. It's fastest around the equinoxes, is slowest around the solstices, which is where the word solstice comes from, right? From the old Latin sol meaning sun and stis meaning stand still, because for about a 10-day to 2-week period around the summer solstice in the north, or the June solstice or the December solstice, the sunrise point doesn't really change that much. It's the same every day for about 2 weeks around those time periods. But on the equinoxes, if you really watch and photograph it, you'll see that there's quite a change day to day in the sunrise position. So it's an ellipse, not a circle, and you can see the Earth's orbit is tilted. It's about 23.5 degrees tilt with respect to the plane. So these two things is what allows are the contributors to the way these photos look that you've seen so far. And the next couple of photos I will show you of subsequent projects that stemmed out of doing the solar analemma. So as I finished years later after I did the analemma, I took a long break, because the analemma was a big saga to get done. It was a lot of work, so I took a break. But I started thinking about the dynamics again of the Earth-Sun system, and I thought, is there another way to depict the change in sunrise, or in this case, sunset position throughout the course of a year? Well, it turns out you can do it in about 6 months. If you go from December to June, you can get the maximum span. You can get the full range from solstice to solstice. And so I did a series of 7 shoots about once a month, starting near the solstice of December 2019 and ending in June 2020. And I shot sunset from a fixed location facing west over our river valley towards downtown. And so on the left, you can see that there's it's the tail end of the low arc of the winter solstice sun that you saw before, it's the end of a low arc setting. And as you look at those arcs of sun dots there, you'll see December, and then January, February, March in the middle, and then April, May, and June. And what you can see is that the curvature of the arcs changes, the spacing changes, and that's all a function of the orbit of the Earth and its Earth's rotation. And so this the size of the sun is one camera again, set up 7 different times to shoot the scene. So that's how big the sun circle looks. And so all of that is represented, you following that rule about making sure that everything is correct geometrically and positionally with respect to the landscape. Because this took a span of about 6 months leading from our winter, from winter into summer, I kind of wanted the landscape to depict the change of seasons. So on the left is a winter, and then blended into spring with the river ice melting, and then into summer with the greenery of the grass in the park and the river valley showing up. Whereas the sky colors are basically trying to depict the sunlight, the sky conditions just after sunset on those three seasons. And so it's a 6-month period, but of course you can look at it from left to right, but you could also start on the right and look at it from right to left, and that's the progression from June back to December. So it does really represent a year, depending on which way you look at it. But it's really 6 months apart doing this shoot. This particular shot was selected is one of the NASA astronomy pictures of the day that Linda mentioned that has published some of my work. So this is me, single photographer, doing this work over the course. And Linda mentioned that Happiness Hour was, she started this as her COVID project. In fact, I shot this at the start of COVID because it became something I could work on, and I was doing it by myself. And so I didn't really have to worry about too many issues or other things hampering the work. And it was very nice to get outside to do this job. So now I'll just bring in some numbers briefly. Where we are here at latitude 53.5, the angular distance in the sky is quite wide. It's about 84 degrees. And so if you know how wide your lenses are on your cameras, it's a pretty wide angle that you're shooting at, which is why the sun looks so small, right? But that's the span of sunset positions between December and June at my latitude. It's about 84 degrees. You can see that the right-hand line pointing vertically, there's a little orange dot by the building. And that is, in fact, I got really lucky with the positioning, that the final sun frame was visible just on the right edge of that building. Otherwise, it would have been obscured by that apartment building. So that ended up just being that I positioned myself I knew more or less where it was going to be, and I was able to pinpoint it fairly accurately, but until you actually witness these things and shoot them, you don't exactly know, despite the great tools that we have at our disposal now to be able to do such things. So another project that I was dreaming up at the conclusion of this one was yet another way to show the sunrise, the change in sunrise position. And so here I set up a camera at one location facing east, and once a month, from December through June through the following December, I shot right around the 21st of the month, which is right around the time that the solstice starts in December. I went to shoot sunrise from this exact spot facing due east. And so 13 images, 13 skyscapes, and I cropped the middle part, made a crop strip of each one of them with skyline showing sun and sky, and stacked them into this vertical composite. And show it depicts, and you can see, if you look, you can see that the sunrise position does in fact change. And twice a year it's due east in March and September. Starts at the top right in December, works its way to June on the middle center left, and then works its way back down to December on the bottom right. And so that was yet another way to depict the change in sunrise position throughout the year. The spacing that you see left to right, those gaps are because of the elliptical orbit. Those are the gaps. Some of it is introduced because I couldn't always get it exactly 1 month apart because of clouds, but it's as close as possible as I could do it. But the spacing does generally reflect the amount of movement based on the Earth's orbit around the sun. This was somebody had done a similar project this a few years ago. I was inspired by this one as well. This picture was turned out really, really well, and in fact, it was another one that was published on Astronomy Picture of the Day. And so if we look up the numbers for the sunrise position, if we find the same thing, we're facing east, so the azimuth numbers are different, but it's the same span of 84 degrees, same span at my latitude. And as I was finishing that project, I dreamt up this other one, and I'd been thinking, I thought, wouldn't it be interesting? This isn't really a skyscape, but wouldn't it be interesting if we could see sunrise around the world on a given day? What would it look like to everybody on the same day? And so I thought of that possibly an equinox, September or March, might be a good time to try to attempt this. And I just chose the September one because generally speaking, based on worldwide cloud statistics, it's slightly clearer in September than it is in March worldwide, but that's just a rough estimate. And so I thought it might be fun to see if I could organize a group of photographers to take a picture of sunrise from their location across all 24 time zones of the world, nautical time zones, and so spanning each of the 24 hours. And we tried to get it on the September equinox of 2022. And as you can see, the mixture was that you don't always get sunrise. Sometimes you're clouded out. So some of these pictures don't have the sun visible in them, but they were taken at the equinox. And we got really close to being able to do this all in one day. The idea was to take these pictures, not only produce this collage, but also I made a YouTube video. I made a video that I posted onto YouTube that animated these pictures that would take the viewer on a journey around the world on a given day to see what sunrise looks like across all the time zones. And you start at the top right in UTC plus 12. This is a shot from New Zealand. And that's the first time zone that sees the start of each new day on Earth. And as you work your way down the right-hand column and then down the columns from right to left, you are traveling westward across the time zones, and you end up at UTC minus 11 on the bottom left, which is in Western Samoa. I found a photographer in Western Samoa to help me take this, to help me do this collage. So not really a skyscape per se, but an interesting attempt to try and depict sunrise around the world on a given day. And so that ended up being quite an interesting video, because it does feel like you're flying around the world over the course of a day, seeing sunrise as it occurs at those 24 time zones. And after that project was done, I kind of got back to thinking about the position of the sunrise, and that's what led directly to thinking about the current project. And of course, I'd done work on longitudes, right, on this sunrise around the world, but it was really latitudes that I started thinking about, the equator north and the equator south. And so I thought, would it be possible to reorganize a group of people? And I had already contacted a number that could possibly participate if they lived at certain latitudes to help me do this. And so I thought it'd be nice to try and get a series of pictures that showed the sunrise position at the two solstices in a given north and south of the equator. And so I looked up the numbers, and I'll show you in a minute which tool I used to do this. And so I came up with a chart that says, okay, if we were to start at the equator and go north every 10 degrees and go south every 10 degrees, we'd end up to about latitudes 60 and minus 60. We'd have a series of 13 pictures, very similar to that stack I showed you of sunrises or for the year of sunrises. And if you look up the angular distances, you can see it that those latitudes, they do vary. the narrowest one is right at the equator, 46.8 degrees. If you look at that fourth column in the middle, and that's at the equator. And that number is significant because it's actually twice the tilt of the Earth's axis, right? So 23.5 degrees approximately leads to 46.8 degrees as a span between solstice sunrises. As you go north and south, you can see that the angular distance or the spacing between does to increase. It increases slowly at first, but as you approach the high latitudes, north and south, it does increase dramatically. It does max out, though, at 180 degrees if you get to the polar circles, like the Arctic Circle at 66.5 or the Antarctic Circle at minus 66.5. And there you'd be trying to shoot sunrise, and between the two, you'd have to have a lens that can do 180 degrees, like an extreme fisheye, or possibly have to do a panorama image to get it. But the other issue there would be that, of course, if you live at the Arctic Circle or north, or Antarctic Circle or south, you don't see the sun come up over the horizon for half the year. And the other half of the year, you don't see it set. So it's really, not only it would be an extremely wide picture to take, it's also not possible to get a sunrise at one of the solstices, depending on which latitude you're at. And so if we plot, so I didn't go to those latitudes. If we plot that angular distance, those positions, to get that angular distance with the position or azimuth on the horizontal axis and the latitude on the vertical axis, if you plot that on a graph, this is what it looks like. So you've got the June solstice on the left, December solstice on the right. You plot the dots and you draw a line, you get this curve. And you can see it's a gentle curve in the middle, and then as it goes up north and goes down south, the curvature extends. And so this was the idea. See if we could get a series of photographs to faithfully reproduce this graph with a set of pictures. And so this project, which I will run you through now, was a project to turn that graph into this picture. So I'll talk a little bit about the planning, a little bit about the recruiting of photographers, a little bit about the image capture and the processing I did, and then you'll see the results as I'll showcase the series of pictures that happened. So the plan was simple: 10-degree latitude zones, or as close as I could get to get the 13 image strips centered on the equator. So that I knew how to do that from the previous project. So 13 seemed to be the right number. So you can get the equator in the middle and then 6 above and 6 below. As I said before, the maximum latitudes would be plus and minus 60 because it's harder to find photographers in the north of those and south of those latitudes, especially in the southern hemisphere. And I used a tool called Photo Ephemeris. It's available both as an app or as a website to find out to see where there were cities or other locations where I might find photographers to be able to shoot sunrise at these locations, right? And so here's a screenshot of what Photo Ephemeris looks like. If any of you do landscape photography, you probably use a tool similar to this to possibly plan your shots, to look at things like, when is golden hour, and where's the moon going to be, or what's the lighting conditions going to be for twilight, and if I put my camera at the red pin, what will I see if I look at sunrise through to sunset, or moonrise to moonset, or even this tool that you plot out where you'd see the Milky Way rising or setting. So I use this tool to plan my projects and also to figure out where I might find photographers. I did this for sunrise around the world, and I used it again for the solstice across the planet. So I needed 13 photographers. 5 of them, including me, were very close to the 5 of the latitudes that I needed to shoot, but I still needed to find 8 new ones. And so I started scouring the web for looking for skyscape photographers that did sunrises or things like that near the latitudes. And that's how I got a hold of Linda, because I was looking to find somebody near latitude 30 that could do sunrise there. And so I needed to find 8 new photographers. That took about 2 months. and lots of emails. You do lots and lots of cold calls on this, right? You contact somebody that you don't know and they don't know you, and you see if they're can or might be willing and interested and able to participate. The one thing I had going for me is that I could give them a couple of links to the previous pictures that had been published on Astronomy Picture of the Day. So I had a little bit of street cred to say, yeah, I think we can get this done. This isn't just not just a crazy idea that that is going to be almost impossible to do. But that took about 2 months to line up the photographers to last June. And so this is what I end up with. Here's a table, kept track of everything in spreadsheets to make sure I wasn't making any mistakes. And so you got the locations, the nominal latitudes that I showed you on the left, the locations and the photographers involved, and then the actual latitudes, which we got close on many occasions. We'll talk a little bit about those a little bit later. And just to show the range of cameras involved in the project, right? It's a mix of the usual big names in digital SLR cameras, right? Some photographers had crop sensor cameras, others had full sensor cameras, right? Others, a number had fairly wide rectilinear lenses. Some had fish eyes. Some didn't have quite as wide of rectilinear lenses, and so they were forced to shoot panoramas in order to get their pictures. Some of them could take single shots, and so there's a whole mixture of sensors, lenses, and whether or not they were going to be single images or panoramas. And so the big thing, of course, was understanding what's the horizontal field, like what's the width of your image. When you send me an image, what's its width? And fairly straightforward to understand that with a rectilinear lens. More difficult when you get into fish eyes because there are different ways of making those. And even more difficult with panoramas because not all panorama stitching software necessarily tells you the width of what you get. But I'll have more to say about on how we were able to overcome those uncertainties. But what the HFOV, the far right column, the horizontal field of view, that's what's important. How wide can you shoot, and how wide were you able to shoot when you actually did the photograph, right? Also, just as an aside, I had to everybody, I had to remind myself and also remind everybody that when you're looking at the specs for your lens, what manufacturers typically give you is the diagonal width of your frame, of your frame, your lens frame. But so that's fine, that's a good number. But what we really need is the horizontal width, because if you go by the diagonal width, you could think your lens is wide enough, but it turns out it won't be because the diagonal is longer than the horizontal. So those are the lenses and the photographers and their lenses, and this is. You can see the red dots on this map of the world. This is the locations. Most of them in North America and South America, although a couple of the photographers that did sunrise around the world, the one in Maui and the one in New Zealand, they had already worked on a project with me before, and then there was one located in northern Australia for latitude -10. But this is where the camera locations were for the project. So when I sent out the brief for the photographers, I tried to keep it as simple as possible and give the photographer as much discretion as I could. In other words, so find the location with a view of the eastern horizon. You decide what's in the skyline or what the landscape is and what the foreground would be. You decide all that. You can use anything you want. You just got to be able to make sure you can shoot the sun as low as possible above the horizon. All right, and to try to use a camera that can get you at least 104 degrees. At the time, I thought 104 would probably cover, at the beginning, I thought 104 might cover everything, but it ended up having to be wider than that at the end for the very northern extreme of 60 degrees north. Or if you can't really shoot that wide, then think about if you can shoot a panorama. And you want to center your frame due east, put the horizon basically in the middle, and then shoot sunrise as low as possible above the horizon, and do this and be able to do this twice, once in June and once in December near the solstice. And as I mentioned before, you get about a 10-day shooting window, 10 days to 2 weeks, where the sun really doesn't, the position of the sunrise doesn't really change very much at all. It's within 1/10 of a degree or so around those dates. And so if you got a string of cloudy days, which some photographers ran into, you can wait and you will be able to get it. So that was the brief. And so then I sent out 2 pictures to the photographers. These were my pictures from the year of sunrises. This was my June 2021 shot of sunrise, full frame, the full picture from which I made the strip. And then I sent them one from December, exact same framing, near the December 2021 solstice. So I sent out the brief with those 2 pictures and said, this is what you're trying to achieve. Just a review of the latitudes. This went out, people photographed the sunrises at those locations. Again, I did not go to the polar circles because they would be too wide and almost impossible to find a photographer there anyway. And so if you compare the angular distance of the nominal locations to what I was able to get from here, you can see that a lot of them are quite close to what would have been ideal. And some of them are further apart or fair distance. The distances are a little bit different than it could be. My own is, I'm not at latitude 50, I'm 3.5 degrees north of that, so I'm a little bit off there. The equator, I happened to find somebody in Quito, so their picture was almost bang on. And some of the other ones, especially like latitude 60, Fort Smith is right almost bang on latitude 60, so it's very, very close. And then at the bottom of South America, at Ushuaia in Argentina, it is only about minus 54.8, and actually not much further south of the equator than I am north of the equator. But it was just almost impossible to get somebody any further than that, and so it had to end there. So that's not very close either. But a lot of them came in quite close to be able to photographically represent this. And so what came in is to review what came in is a mix of single or panoramic images. Most of them were rectilinear, although there were a few fisheye lenses involved. And every pair of images, though, each photographer sent in a pair of images, other than there was one exception, to get had the same sensor lens. And so they used the same thing twice. There was one exception. And there was a mix of different horizontal fields of view, of course, because of the different camera sensor lens combos and different pixel scales, depending on the size of the sensor itself. Slightly different framing, because you can't always point at, exactly due east. When you stitch panoramas together, especially if you got to join 2 panoramas together to make something, they're always going to stitch slightly differently, and so that can be a little bit different. And not everything could be shot at the widest angle, at the widest horizontal field of view, and that's why, if you recall, in the eventual image, there's black areas to the left and the right of some of the strips, because it was just not possible to get everybody to shoot at the maximum width. If I sent out a bunch of cameras and lenses to everybody, and we might have been able to do it, but that would have been been a big expenditure. And this was all done on a pro bono basis by everybody. We had the 2-week shooting windows around the solstices, so not everybody could get it right around the 21st of the month, right around the solstice. And also sometimes low cloud or other horizon obstructions meant that the altitude above the horizon did vary, right? And so the golden rule that I talked about in doing all of the work that I generally do of the 1 camera, 1 lens, 1 focal length, 1 camera position, that's all out the window, right? That's all out the window with one of these. But if you boil everything down, there's really just 2 factors that had to be addressed to really be able to bring the essence of that rule back, which is to produce a faithful photographic representation of the solstice, sunrise azimuths or positions, right? The differences in camera lens sensor combinations meant different horizontal fields of view or pixels and pixel scales. So that was one factor. And the other one is the slight differences in camera position and aiming. And so the frames of each pair that came in would be different. Right? But there is a way, there is a way to be able to address those 2 factors to get it as if we'd done it with 1 camera, 1 lens, 1 focal length, and the same position every time. So the tools I used to do this I use GIMP for my photo processing, which is quite a powerful image editing program. And its best it has many plugins. You can do just about everything you need to do. And its best feature is that it's free, because it's open source. I used Huggin Panorama Stitcher, where I had to deal with some registration and scaling issues, and I'll talk about that again. And again, I had to use photo ephemeris when I had to get the information about each photographer's pictures when they sent them in. So there's GIMP, which you can get at gimp.org that I use. There's the Huggin screenshot, where you bring in pictures to stitch together a panorama. Also open source, developed during Google's Code of Summer, I don't know, 10 years ago. Been extended ever since. Works quite well, also free. And then the photo ephemeris, which has both free and paid options to be able to set your pin down and take a look at the circumstances of the type of picture you want to take. And so in this particular screenshot, you can see the pin is set up at the top of Haleakala on the island of Maui, which was the latitude 20 picture that my buddy had taken, who had participated in sunrise around the world. And so assembling the final image is really where I'll tell you how this came to be. It needed basically four basic steps. Step one, prepare the image pairs as they came in. Step two, scale them. Step three, shift them. And step four, assemble the final stack. So here's I'm going to run through one example and show you how the rest was built. So here is the two pictures submitted by Chris Prazak in Houston at latitude 29.8, almost 30. And so he did two single images with a rectilinear lens, same camera lens both times, almost very precisely aimed east. And so all that was really needed for this pair was to register and align them using the horizon. The horizon is very close to the same in both pictures. So I just registered those in GIMP, and that's all that needed to be done to prepare that image pair. One of the photographers in the Southern Hemisphere could do December, but then they moved and it wasn't possible for them to do, or they did June, and then they moved and they couldn't do December. So they got a colleague of theirs to do December. And so two different camera lens combos were used. And so these had to be remapped to scale and register and align them. And so the panorama stitcher comes in handy, because what you can essentially build, it's like a panorama, except that the frame is going to be almost nearly the same that you stitch together. And that brings them into the same horizontal field of view. And then some images were panoramas. So the photographer in Darwin, Australia, had to shoot panoramas. And so he sent me two panoramas. And I didn't know their widths, but I had to still had to remap them at least to the same width. And so it plucked two panoramas into Huggin rather than single images, and restitched them together so that they could come out to the same scale. And so you can do that in Huggin as well. And so what you have at the end of step one is you have, for each of the 13 latitudes, you've got a pair of aligned images at some pixel scale, right? Whatever pixel scale they happen to have achieved. However, the pixel scale is different for each latitude. And so that's got to be dealt with. It's got to be brought to the same thing. And so to scale the image pairs, I decided I'll use my images, which I know best, and just set that as the common pixel scale. And for all the other 12 latitudes, because the sun is visible in each image, that's the key. You may not know the width of the image, and you may not know the distances involved or what's in the skyline or anything like that. But what you do know is that the sun is in the image, and you do know when the picture was taken. And so using the EXIF timestamp of when the picture was taken, as well as knowing the location of the camera with its coordinates, right? You can figure out where the sun is in the sky in that picture. In particular, its azimuth. So that nails its position. independent of everything else in that photo, because the tool, the photo ephemeris tool, can get you that. And so therefore, between June and December, you can determine that angular distance using the sun positions, and then you can determine the pixel scale for that pair. And then once you know that, it's a simple matter to do a scale to the common one, which is my pixel scale at 53.5, right? So I'll give you a brief example. So here's my picture for June solstice at latitude 53.5. And when I took the photo, the sun is at 49.2 azimuth, right? Repeated this 6 months later. Here's my December one. It's at 133. And if you look at the two together, there is that very close to 84 degrees width. So I know the width of this image, and I also can, because I know the number of pixels involved, I know what the pixel scale is, so 42.7. So this became the fixed thing. Everything else had to be scaled to this. So here's an example. This is Stan Honda's picture from Manhattan, shooting, well, not from Manhattan, but shooting Manhattan at the June solstice. And if we look up the EXIF timestamp, you use daytime original in the EXIF. I told all the photographers, make sure your camera clock is right when you take these photos and it's correct, right? So you use that to know the date and time, and you know the camera location, because I asked everybody to provide me their coordinates. Go into photo ephemeris, put the red pin down, choose the date on the top left, put the red pin down so you have the coordinates on the top right, and then bring the time bar to the time of his picture, and you can see in the red box that the sun's azimuth at that location is 62.8. And it also tells you the altitude of the sun. So in this same photo, it's at 62.8. The sun's at about 5 degrees above the horizon. And so this put a constraint on Stan for his picture 6 months later. He needed to have the sun about the same height over the horizon. Because if they were different heights, there would be different spacings involved, and we needed to keep that consistent. And so I knew that. Look up his December solstice image taken from the same location. It's that. And so you compare the two. So his width is 63.7 between suns, and his pixel scale is 30, different than mine. So you have to be able to bring them to the same. So if you put them on the same canvas and line them up center to center, you can see that Stan's images at his latitude, the suns are narrower than my suns, which is correct because he's closer to the equator. But is the amount of spacing correct? Well, it isn't exactly, because his pixel scale is different than mine pixel scale. So he needs scaling to bring it up to mine. So if you do that in GIMP, it's a simple matter of doing a scale based on the percentage. His picture looks like this, as if he'd shot it at the same scale that I shot. Still narrower, but now scaled properly. So I had to do this with 12 image pairs to be brought in. So this is just one. I did it for all the others. So now at the end of step 2, we have 13 latitudes, aligned images, all at 1 pixel scale, the common pixel scale. But the last problem to resolve was they're not always aimed due east, right? There's going to be slight differences in aiming. And so again, we're going to use the sun's, the position of the sun in these pictures to resolve that problem, because we know its coordinates. So if we look at this picture again, I decided I'll use my picture at latitude 53 as the fixed base. Everything has to be positioned so that it's accurate compared to my picture. And so let's look at the left half, which is just June. We're going to convert the angular distance between my latitude and the other picture's latitude, right? So you can see it goes from 49.2 to 62.8 at the same scale, right? And so you just subtract the two to get an angular width in the sky, and using the pixel scale, which is now set at 42.7, you see there's a difference of 580 pixels. And so what Stan's picture has to be shifted so that the sun is in this particular example, would be 580 pixels to the right of my sun. And so if you look at it, that's the shift, right? So that's, if you just line them up center to center, that's what it would look like. but more accurately, that's what it looks like. A very minor shift, but it's calculated based on the position of the sun. So you're being accurate with respect to the geometry of the situation. So I had to do that for all the other 12 latitudes, what I just did for this particular one. So at the end of step 3, we now have 13 latitudes. Each pair is aligned at the common pixel scale, and the pairs are horizontally shifted to the correct position. Now the images are ready for assembly. So we get to step 4, which is get that image stack built. So I put them all into GIMP, into an image canvas, and I defined a best fit selection rectangle to create an image canvas that would contain the bulk of all 13 images, because they have different widths and heights, and it needed some kind of a selection rectangle to create some nice images to display. And this particular canvas and these rectangles serve two purposes. I could then crop them to put in a movie that animates the images that are used to make the stack, right? And also then crop the images into strips to assemble the stack, just like I did for A Year of Sunrises. And so I thought about showing you the movie, but you can watch it at your leisure on YouTube. The link is in the chat to my YouTube channel, where you'll see a link to the movie. But I'll show you the pictures and essentially how the stack was built, because everything's now ready to crop into strips and put together. And it's just a matter of stacking them. And so this is Fort Smith, latitude 60 in June, wide panorama. There it is again in December. There's the two of them put together. There's the strip, and it goes to the top. You've seen this before. This is a crop of my image, which was the base for everything. December or June, and then again in December. There's the two of them together. There's the strip, and you put that below. But now the center line, the divider between the two strips at the center is more or less at the center, is actually at the center of the stack. There's Stan Honda's picture in towards Manhattan in June. Saw this in the example. There it is in December. There's the two. There's the strip, and you put it up there. You can start to notice the black areas on the left and the right, because not everything was could be shot so wide. And I also, I introduced a couple of framing errors in when I gave some instructions that turned out to be poor for the second of the shots to a couple of the photographers, and so I probably caused a little bit more black area than would have been possible, but that's the way it went. Here's Chris Prazax. You saw this in the example, shot in Houston in June. There it is in December. You can see the foreground shifts a bit, right? The fence right in front of the photographer shifts a little bit. But the important part is that the horizon doesn't shift all that much or at all, because they are registered. The two images are overlaid and registered. And so when you put them together, you can see the fence maybe doesn't line up properly, but it doesn't really matter, because the importance of this picture is to make sure that the sun and the horizon line up accurately to depict this strip, in which you don't see much of the near foreground. So then you put that in. Here's my buddy in Maui, Rob Ratkowski, took at the top of Haleakala. That's his June solstice picture at the top of the volcano, above the cloud deck. There it is again in December, a framing issue that I introduced accidentally. And again, above the cloud deck, there's the strip. There's the two together. There's the strip, and you put that in the stack. Latitude 10 was in Guanacaste, Costa Rica. Found a photographer that works at the airport there, and he really had trouble with the clouds last June, a year ago June. It was almost impossible. There was a thick curtain of clouds that didn't really clear until the sun was fairly high. This was the highest altitude above the horizon for any photographer. Luckily, though, the closer you are to the equator, the the more vertical the rise rather than slanted the rise of the sun. So the position left to right doesn't really change all that much, even though he had to go higher. But it was the best that could be done. And it took him the full 10 days to be able to get even this. So we went with that because I figured we could make it work. And so then 6 months later in December, of course, he had really clear skies. You could shoot it at just about any altitude that was necessary, but it needed to be at the same altitude in order to make sure that the distance was consistent. So there's the two together with the framing. The original June shot wasn't quite framed facing east properly, but it still worked to make the strip. And you put that in. Then we get to the equator in Quito, Ecuador, where Henri Leduc was able to get this shot right out of his apartment balcony. He had a lot of trouble with clouds over the solstice last June, their winter, and he only basically got the one day, a few days after the solstice, was able to get this spectacular sunrise picture with awesome lighting throughout the whole scene. 6 months later, he had a kind of a cloudier day to be able to do it. He was able to get it at the same altitude, very hazy atmosphere. In fact, you get the bonus of the sundogs in there. And so the near foreground shifted quite a bit because of the panorama. It doesn't really matter all that much because when you put the strip, you put them together, you line up the horizon and you put the strip together, that's the distance, the minimal sunrise distance between the two solstices on the planet at the equator. Put it on the stack. Then we get to -10, we're at -12. Darwin, Australia, a panorama. This is their, their winter, which is for them is fire season. So they got lots of wildfires in Northern Australia. And so that's why that foreground is very black looking. That's because the result of a wildfire that it swept through. So he had fought a lot of wildfire smoke was fighting to be able to get the shot. 6 months later, he gets it on their summer at roughly the same altitude. The panorama, put the two together. There's the strip, and there's the image stack. Antofagasta, Chile is where Farid Char, who initially signed up to do the project, although he had warned me that there was a possibility that he might have to move for work. And so, but he'd be able to find a replacement for himself. So I said, let's do it. So there's a shot from the June solstice. He did, in fact, have to move. So Maglio Cordero ended up shooting the December version. Different camera, different lens, different framing. And so I had to do a registration with the panorama stitcher to get things, to be able to align the two horizons to get this shot from the Chilean Andes, make the strip, put it in the stack. Egon Filter in Brazil, near latitude -30, had participated in the sunrise around the world, and he got this great shot in June. The sun just peeking up over the horizon. And then there's his December solstice shot with everything greened up for summer. Pretty straightforward to align the two. And there's the strip and the stack. Chris Pegman also participated in sunrise around the world. He lives in South Island of New Zealand in Christchurch, so he has some great hilltops he can go to get some spectacular shots, although sometimes they're hampered by fog and low-lying cloud that could cause issues. But he did manage to get this June solstice shot after a few days of fighting low-level cloud on there. And then again in their summer, it was a little easier to get it at the same altitude. Fairly straightforward to align it there. What looks like a misalignment on the mountain in the middle there is really that the clouds blocking some of the top of the mountain, and so it looks like it's funny at the horizon there, but it's not, because part of it's cloud and part of it's clear. But that's just the way it goes with pictures 6 months apart. There's the strip. He also was shooting a fairly you go back. He also had got the sun at fairly high altitude above the horizon because of low cloud. And that's what forced this particular strip to get it into here. And then as we get down into south of Argentina, or El Calafate in the Argentinian Andes, Alejandro Capelli was able to get this great shot um, last year ago, June, and then he repeated and got some spectacular, quite cloudy, but very, very good lighting to get the sun right through that cloud gap in December. To be able to put those two together, fairly straightforward. Get those horizons that composite to align the image pair, make the strip, and put it in. And then finally, we get to the furthest latitude which we go, which is at the bottom of South America in Ushuaia, Argentina, which is a place that many cruise ships stop at to when they do a tour from around the Horn, or around the bottom of South America. And so there's a mountain range there, of course, and so the sun's altitude was constrained by the sun peeking over the mountains in his view, and so therefore that forced his December shot to take the shot as well there, and then align the two to get it. There's the strip, and you put it at the bottom, and that completes the stack, and that is the end result of the project. So you've just seen all of the pictures that are featured in the video. The video has some explanatory information at the beginning, takes you through the images and shows you visually how the stack is put together, if you'd care to watch it. But that is the picture, and that brings us to the end of the presentation.
My gosh. All right, let me get you to take your screen down.
Sure.
This was so cool, Luca. One, I'm gonna say I'll just throw myself on and embarrass myself and say I am so glad that I was not able to participate, because I think I would have totally screwed this up for you. So thank you, Chris Prezek from Houston, to represent our latitude. So, but this is how I'm going to contribute. Because you came and did this presentation for us, you'll be able to share this link with each of your participants so they can kind of see how it all came together on your part too. So
I will do that, definitely.
yeah. So this is so cool. It was way over my head in some parts, but man, first of all, getting all of those people to coordinate and be able to send you what you needed, that is really impressive. That's really impressive. There was a comment in the chat earlier, and I'll share this with you, but somebody said, you took a very technical subject and made it we could follow it. I mean, you lost me a little bit when you was talking a little bit math, but I'd warned you that don't throw numbers at me.
Right.
But just the visuals and the execution of the plan. So will you do this again?
Well,
with a whole group of people?
Well, that's going to be tough, because I started thinking about what other interesting things could you do, but done the longitudes, then the latitudes, did the whole year, and it's at the moment I don't have an idea of something collaborative like that. But to tell you, there is a project that I am working on. It's strictly at my location, though. It's for yet another more subtle effect, not only of the sun's position along the horizon, but also the moonrise position, which there are related cycles. And so it takes a year to do it, but because you can't get the moon, doing 13 moonrises in a row is almost impossible, because you only get one chance of a full moon a month. And it's almost impossible to do it, as experience has shown. So a buddy of mine and I are collaborating to get a project done, but it won't be ready for another year. But after that, I don't have any other plans, because they do take a lot of work. And also, there aren't that many geometrical things that you can line up to demonstrate the dynamics of Earth and Sun, or Earth and Moon, right? I think I may have exhausted the possibilities, but who knows?
You'll think of something. I'm looking at the comments, and I will share this with but I'm going to read
Okay.
one from Susan.
Okay.
Your presentation is brilliant and beautiful, and it was a very creative project. So I'm impressed. Susan's impressed.
Thank
Um,
you.
this is really, really cool. My little brain cannot even come up with stuff like this. So I'm fascinated. And because I have such a huge love for travel, to see all these different locations and the results that everybody, turned in, it was super neat. So thank you for
Actually,
sharing.
one thing I did think about doing was to go on a trip and go visit all those locations and meet those photographers.
Oh, I think you should. I think that would be brilliant. I think that would be absolutely brilliant, to go to those locations with them and say, that's really cool. That would be like a nice way to tie a bow around this project.
And of
So,
course, do it in June or December, right?
right. Yeah. Get that passport ready. All
Yep.
right, Luke. Thank you for coming and sharing this project, because this is, it's when you take your ideas and you piece them all together, and you've got a project that you want to share, and you send it out there, and you don't know who's going to see this or what someone's going to take away from it. Me personally, this is something I would have never ever conceived of doing. So that's just really cool to be introduced to a different type of thought process.
Hmm.
And so it's fascinating. So thank you so, so much.
Well,
And more importantly, thank you for letting me turn the table around on you and say, hey, why don't you come and do a presentation for my group? So I did nothing to participate in your project, but I sure appreciate you coming in and participating in mine.
it
So
was my pleasure to do it. And now that you all have seen not only this project, but even some of the skyscapes, you might want to do some projects around your cities. Just
yeah.
shoot your own city once in a while to see if you can come up with your own skyscape or timescape, just featuring your own city or where you live.
Well, as long as I can limit it to sunsets, I might be persuaded to do it.
Sunset is just as good as sunrise, and and actually, where you live, you never have to get up at 4 in the morning to do a sunrise.
Exactly. That is true. That is very, very true. But even those 6 a.m. ones are just like cringy.
Hmm.
So I am a lazy photographer sometimes. All right, Luca, thank you for coming. Thanks for sharing. All right, next week, wildlife photographer Melody Lytle joins us with her presentation, Photographing Things Which Fly, Birds, Bats, and Insects. So until next time, go out and create something beautiful. And I hope that we see you again soon.